Welcome, Ichak Solution, Loci Complex Numbers Lesson 3. So if you haven't watched Lesson 1 and Lesson 2, I would encourage you to go and look for Lesson 1 and Lesson 2. Alright, so I would also encourage you to use the ruler and compass and make some scale drawings, right? So let's go here. Right, so in this question they are saying sketch on the same Argand diagram the region which satisfy modulus of 2z plus 4 less than 8 and real of z greater than or equals to minus 2. Alright, so you can see we have two regions here that we need to combine together, right? So let's go here. Alright, so the first one is modulus of 2z plus 4 less than 8, right? So here we can factor out modulus of 2, so we factor out modulus of 2 here. Alright, then we divide by 2 both sides here, so we are going to have since modulus of 2 is 2, so we divide both sides here, so it's going to be 4, so it's z plus 2 less than 4. Alright, so the next thing now we can effect a negative here, so it's going to be z modulus of z minus open brackets 2 open brackets minus 2 plus 0i less than less than 4. Right, so now you can see here the center is minus 2 0 and the radius of 4 units. Right, so now let's sketch the circle here. Right, so the point minus 2 0 is here, then the radius of 4 units, we place a radius of 4 units, then we are drawing a circle with a radius of 4 units, but the circle is going to be a broken circle because the points which are on the circle are not included here. Alright, so we sketch the circle. So now we shade inside the circle. So we are shading inside the circle because the distance from the point minus 2 0 to any point which is inside the circle will be less than 4 units. Right, so let's go to the other one here. Real of z greater than or equals to minus 2. Right, so z is a complex number, so z can be written as x plus yi, right? So real of x plus yi greater than minus 2. So the real part here is x. So we are just saying x greater than minus 2. So here it's a straight line at x is equals to minus 2. Then it's also a region where we need to shade. Right, so now we draw our real axis and imaginary axis. Then the line of x is equals to minus 2. It's a continuous line because the sign is here, it's greater than or equals to. So the points which are on the line are included here. So now we shade the region which is greater than minus 2. So the region which is greater than minus 2 here, it's this right side. So we shade this side. Right, so now we want to combine these two regions. Right, so let's combine here. So this imaginary axis, real axis. Right, so we have the first circle that we have here. So we put our center at minus 2 0 and a radius of 4 units. Then this is our circle. Alright, then we also have this line of x is equals to minus 2, which is continuous. Alright, so now we need to combine the first region and the second region. Alright, so combining the first region and the second region, it will be this part. Right, so we share this part. Right, so that's the intersection of these two regions. Right, so let's so sketch on the same Argand diagram the region which satisfy modulus of z minus 2i less than or equals to 2 and real of z greater than imaginary of z. Alright, so let's go here. Alright, so we can now first break the first locus that we have. So it's modulus of z minus 2 plus minus 2i less than or equals to 2. So you can see it's a circle here. Alright, so we effect a negative, so it's going to be 2 plus 2i less than 2 here. Alright, so the center is 2 and 2 and radius is 2 units. So we sketch imaginary axis and real axis here. Right, the center is at 2 and 2. Then we have a radius of 2 units. Alright, then we sketch our circle, which is a continuous circle because the points on the circle are included as per the equal sign here. It's less than or equals to 2. Right, so now we need to shade the region, right? So we need to shade the region which contain the points such that the distance from the origin to that points or to any of those points will be less than what? Will be less than 2. So the point will be inside the circle, because moving from the center to any point inside the circle, the distance will be less than or equals to 2. Or moving from the center to the point on the circle here will be equals to 2. Right. So this is the first region that we have. Right. Then we go to the next one. Real of z greater than imaginary of z. So z is a complex number. So you can say let z is equal to x plus yi. So we are going to have real of x plus yi greater than imaginary of x plus yi, right? So which means the real part here it's x on this complex number, then the imaginary part here is y, so it's x greater than y, right? So x greater than y can be written as y less than x, right? So we need to draw a line of y equals to x, then we share the region here. So let's see here. So we have the imaginary axis and the real axis, and our line of y equals to x is a broken line because the points on the line are not included here. So it's going to be y less than x. So we draw a line of y equals to x here, right? So now we need to share the region. So we need a region whereby y will be less than x. So if we take any point here, points in this region, those points, let's say at this point, right? So at this point y will be less than x. At this point y will be less than x. At this point y will be less than x. So we are shading this region, right? So now we want to combine these two regions, right? So imaginary axis, and we sketch our real axis here. All right, so now we start by plotting the circle. So the circle at 2 and 2 here, in a radius of 4 units, and this is the circle here. Right, now we put this line. We are going to sketch this line here. Right, so this is the line of y equals to x, is a broken line. So now we want to combine these two regions, the first region and the second region here. So we are going to shade this part, because that's where they are overlapping. When this circle and this region, the shaded part overlap, they are overlapping at this region. So we are going to shade this part. Right, so that will be the region which satisfies the two inequalities. All right, thank you for watching the video. See you in the next lesson.